Hi, good morning. Today I'm just trying to go through some learning and coding practice tutorial, whatever you can think. I'm also learner on this all this stuff. So what I'm talking, I wanted to go through AI. Artificial intelligence, machine learning, with basics using .NET framework, that is ML.NET is an open source engine which is by Microsoft. Okay. This is what I'm about to bring. What is AI, what is ML, all those things. Just to save time, I'm just going with this copy paste quickly. So, artificial intelligence. What is artificial intelligence? You have some intelligence. When we will say one person is intelligent, when he has something he is doing in a better way, better proven the best way. It's not like I'm a good but I'm doing it in a worst way, then I don't be called as intelligent. Okay. So intelligence used in the best way. You use it for good or bad, that's a different topic. AI can be used for good or bad, but intelligence means how you do in the best way. Okay. Now artificial intelligence, it means human intelligence is what we are doing. Artificial intelligence is, it does with the perfection and some more all those, instead of one human intelligence usually by one person. Artificial intelligence means it is a collection of multiple persons into one systematic way. It's called artificial intelligence. Okay. So for the best example I just brought, you have 1,000 emails. You have to divide those emails into the necessary or financial or something kind of. If you are going to do through human, it takes nearly a day for 1,000 emails. Even to it will be, you can make it up to 100 emails, but how do you make it? Before that you have to decide what you wanted and what to delete and what to keep, all those stuffs. So totally you have to be decided yourself. Okay. This decision before you do, that is the most important stuff. Okay. Normal coding, in the normal coding way, how we do, if the email contains this particular word, then consider. If the email contains this particular word, then ignore or move it to cache or finance or whatever you can think. So that is how in the normal coding we do. How it is different in the AI, yeah, I'll come to that. Now before that, in AI and ML, AI, artificial intelligence, how the machine learns, how the machine knows all these stuffs, that is through teaching. Means machine is self learning, that is called machine learning. So you, how the machine learning works, it learns with the help of data. If you provide the data, even as a human, how do we learn? We will learn by either our mistakes or other mistakes, or how the way other things. Totally we have to learn by something else. That is the greatness of human and system, same both. Okay. So that is how totally we have to train any person. Okay. Yeah, that is where machine learning. So machine learning is the one where you have to feed the data with some proper pattern to become expert and keep growing. I mean to say, you have to feed the data to the system with some pattern uh, to system to become expert and keep growing. Okay. That is where it means you have to train or load the system. Training means by loading, apply it on some algorithm to get some model. And once you get that, you will get some kind of a system is model is ready. Then you have to validate through test data. Once after testing, then you can go for prediction using inputs. Okay. uh, okay, I hope it's clear now. Okay, so totally you have some test data, you have proven. It could be any data, anything. If you take the example of 1,000 emails, if you have some 1,000 emails in one, hundreds of users collecting those 1,000 emails and categorizing each email. This email is about finance, this email is about health, this email is about government. So like that, if you categorize and keep the data everything loaded, that is the reason if you go to anywhere, they will be keep collecting the data. The reason for the data collection is not so simple, silly topic. It's for learning for themselves. Even how the hackers and all they do it, they will learn from hundreds of thousands of users, and they will apply that knowledge to someone else. He becomes a victim or become a the last person. Okay. This is about how machine learning concept. Now this machine learning how to make, so as I was telling, train the data, so it goes in some little sequential pattern. So I just brought in some steps. First step is, here I have just taken one more example with little more. Email is not enough. Even email you can do it by human being also. But one advantage additional advanced concept is, you have thousands of birds sounds, the data. Using those things, you have to identify the new birds. If, for example, you're going to be a forest of Sahara, I mean, some Kunu or Amazon or any other Sayhadri forest or anywhere, at that time you have to identify some bird sound. So before you going, what you should do, you have to be prepared with all the stuffs, like how do you do jacket, shoes, all those things. Same way here, you are loading the data to the system. Okay, loading the data to the system first, and then whatever you have loaded before in the real time inputs, those should be in the proper shaped manner. It's not like you have some tiny or some machine sound engines and all those things. Just filter out and try to keep the proper data. Machine learning itself totally works with the help of data only. Okay, coding is not a big deal. You can do it very simple, a very easy way, one or the other way. If you google or use some chat gpt or anything, you will get some stuff. So but you have to understand the concept. That's why I'm just trying to go all these things. Load the data and retune it. So from that, once you retune means proper filtration, you can say reshape or filtration, whatever you call. Okay, and then by that you have to make it into system understandable binary format. It means some vectors, you have to standardize it. Okay, once you retune it, you have to apply an algorithm that, I mean, whatever I just told here, I'm just explaining those things in terms of steps. Okay, nothing else I'm doing. Reshape it and standardize it, and then pick an algorithm, use that algorithm, load data to this algorithm and get a model. That's called fitting. And then model testing by test data means, you have to, once you made it fit, you applied the fit, it becomes a model is ready. Here, model is ready. Then use that model engine to get the test data, get the accuracy, like some whatever the 50%, 80%, all those things, you will get the result with the test data. I mean, you're validating with the test data to measure your engine. Okay, first you're measuring yourself. It's just like a preparatory exams, how we do it in the college or something. Same way, if the person is okay, I mean, for example, if there's a guy who is going for olympic, then you are just preparing him the zonal level or country level. Okay, he's good, then you send him to real time to olympic. Same way, we are validating the accuracy. And then once it is done, then you are going for the, I mean, if it is not satisfied, you have to retrain more. Okay, I mean, step 1 to step 6, again you have to repeat until you reach the expected outcome. Once everything is satisfied with the metrics, then use for further predictions in real time. Eventually, system will be keep evolving on every time input or trials happens in a circular way. You have to make, it's not optionally. Okay, this is the total funda of whatever you call. Okay, now just few more terms we have to understand in terms of .NET now. .NET, I think in other place also, I know .NET. I am also a learner. Okay, and just to be frank with you all, so whatever the data we have, that's called features. Whatever the outputs are called label. And once again, I'm repeating, probably just like me, who all here, I'm considering they know some technology, some stuffs, especially it could be .NET, C Sharp in some different background, or some OOPS concept, those kind of stuffs. So they are comfortable with input, output, these kind of normal coding convention. So now I'm trying to correlate the same words here for this explanation, so to be useful for others. Okay, so now maybe just to make you clarity, if there is a kid, okay, kid, once you teach 1 to 100 or some 1 to 200, for example, it will be able to identify the numbers from predicting 1 to infinity. This is called human intelligence. Okay, if you teach for 1 to or 200, then you can do it. Okay, while doing, I just got a few of the errors. I'll just tell you, I just noted down whenever, just one step before this video, I just recorded these steps. So if you enable console I mean, we are trying this in the console application. At that place, I had enabled ahead of time, so which makes it will not work, because ahead of time is not supported in .NET framework currently. That is one thing. And this is another error. I'll just come to this. Okay, let me quickly jump into the code. This is not completely, this is a learn and code, but I should have not coded all these things, but still I have coded. I'll just be using this to say the timings. Okay, so I was just trying to tell, there is a input step. I mean, first is okay, one more important stuff in .NET. uh, what is this? .NET has a solution. It's called ML context. Okay, ML context is the main entity, which is just like DB context from Microsoft. Okay, so this is the one entry point for everything. Okay, same way. Let me jump in. So here you can see using ML context. First, you initiate that object itself is everything for machine learning in the .NET framework. Maybe there are other things, but as a learner, you just consider these things. You have plenty of other things. The world is infinite. Don't bother about all those things. Okay, now iData view, what is this? I'll just tell you. First thing is, okay, before coming to that, you have to load the training data. Load training data means it's nothing. Let's assume you have some files of data, you have any number of Excel document, infinite gigabytes of data. That's a different thing. You are using some data to train the system. Okay, in this function, nothing. I'm just using some simple C sharp or simple list. I'm just keeping it in one list. It means you can create one simple list and add the data. That list, it's this is nothing. This list is a simple filling input. Here what it is it's having some two fields. Emotion, it's just a simple text. I am just trying to keep while teaching. This is not output, input, data, result. It's not okay. Here you can see input data, uh, teaching result, you can say. I mean, whenever you are telling the teaching the system as, if I tell emotion, hey, I'm good, then that is called positive good. If I'm say I'm boring, then I'm telling the system as false. Like this, I'm teaching the system with this structured data. Okay, now coming back to the system. So here, whatever we are, the data we are teaching to the system, I mean, this machine language engine or whatever you call system, totally I use it as system means it's a code, you can think of whatever. Here it expects the machine learning. Whenever you are writing any code, for example, whenever you're writing any code, it expects some parameter in some structure, like how you talk to some English guy, you will be talking with in English. How do you talk with some Hungarian guy, you will learn Hungarian. Okay, some different language, you have to talk in their language. Okay, so in the same way, for this ML context to load the data, you have to keep it in the form of iData view. It's just an interface, nothing else. Don't worry much about it. iData view is for the sake of machine learning. You can see here the input and output of query operators. This is, you can see this is Microsoft.ml.data view. Okay, it's derived from this. By for link you, this is the one data stuff. Okay, now you have to keep the data in the iData view, nothing else. Okay, so here this feeling input, whatever I have, this list I just load it to this. Load from any variable means you can load from different source. You can load from database, load from binary, load from SVC, load from text file. There are tons of it. Don't worry. You can, once you learn one thing, then you can do anything else. Okay, I data view, totally you prepared with this data. In this data, with this data, what you can do is, earlier days, probably just 1 or 2 years back. Now I'm recording this video on the year of 2024 January. So just 1 or 2 years back, how you used to do, you're keeping separate list data for input, separate for, I mean, test data, training data, all those things. I mean, as I was telling, in the system, so you can see here load data. This is called load, you can say, training data. Okay, I mean, you have to train the system. Okay, uh, then testing data, model testing by testing data. Okay, so in the same way, but what is training and testing? Both are same. Both are same means different values. Okay, so you have to maintain separately. So that's what, here also you have data. In this data you can keep, like, how much data you wanted for testing, how much data you wanted for training. Okay, so here I'm just telling 0.4%. Okay, if I can tell 0.20% for testing. Okay, remaining all is for training. Okay, it goes, you can there are many things in on top of this, but don't worry, it is the concept is this only. Here it is model context, ml context means whatever I created, dot data dot train test data. Okay, simple. And then you created the data, and then email context dot transforms means whatever the data you have the data, that data you have to be transformed into vectors in the sense this is the one which machine is understandable. I mean, you must be knowing computer itself means it's full of zero and one, nothing else. Same way, this machine language is little advanced. Here, what they're making is you need some data in some number, some conventional format. Okay, for that, you have to do is the convention is featureized text. I'm making it as featureized text. You have a number of options, just like text. Okay, sorry. Uh, what is this? Featureized. Yeah, okay. Sorry. Okay, it's already here. Featureized text. Here, I'm trying to tell there is output column called features and input column is emotion. What is this meaning? I mean, I have the data, right? In the data, you consider a column name of input feeling input dot emotion. Here, I just made it right. So in this emotion is there. Take it as an features. Okay, column name is features. I mean, I think different also works. Better go with this. Features and label is a standard convention is using. Your Microsoft also recommending same for their complete structure. Okay, here you are trying to tell data process pipeline. Here output column name as features. Again, I'm repeating. Here data inputs are called features. Don't get the confuse the name. Inputs means this is the input for engine. Okay, here you can understand this particular pipeline for this particular step. Whenever you do this, the output will become as a features. Okay, this data process pipeline, I will just go once again. Okay, you just created using your data, you generate the output called features. Okay, first step, one step, I mean in the step two. Then you choose the right model, you choose the sorry algorithm, pick an algorithm, right? Algorithm depends upon your case. Here I have chosen this ml context dot binary classification. There are number of options, model dot many other things. Don't worry about those things. So binary classification is a simple one. So dot trainers dot sdca logistic regression. There are many things, don't mix all those things now. And then once after this, whenever you are applying this log algorithm, you generated a result, right? That result will be stored into where, that is to label column. Okay, what is the feature column name? You can see here the parameters. You can just observe your label column name and feature column name means Microsoft is recommending the convention of label and features because they are maintaining like that. So it's better to go with the same way. Instead, you can make, if you make it input and output, then you will be messed with it. Okay, so better go with the world how it goes. It's easy to go flow towards the wind. Okay, the same way label column name is label means this will be the result of this particular algorithm model. Okay, so feature column name is this is the input, that is as a features. Take these features and so get move the result to the this one. Okay, this is a trainer. And then data process pipeline dot append trainer, it means it is a trainer logic. Okay, here actually this ml context probably over comes from .NET core. In the .NET core, how it works, just a program.cs, it will be just executes the series of execution, that's called pipeline. Same way here also, pipeline pipeline pipeline, nothing else. Pipeline of execution. So here this data process pipeline, for that you are attaching this trainer. Okay, once you attach, the training pipeline is ready. Once you are training pipeline is ready, you do what, you training pipeline, this pipeline you fit that with this particular data. Training data means whatever you have loaded the training data here, that data you made it to trained model. Okay, so with that the model is ready. Okay, here model is ready now. Okay, first model is ready. Then using that model, you have to just validate yourself first. For that, you are using the trained model, this particular model dot transform with test data, with the particular test data, whatever we left here, 0.2% or whatever it is, that gives the predictions, means how much it is and all those things. This particular predictions, how much good it is, how much bad. So for this again, you have to measure the metrics, means it's just a simple convention of normal programming, nothing else. Here, do the result as, this particular predictions, take it, label column name as label. You're evaluating, that's what. With the result set is stored as label, that you take it. Score column name, that is this score column, that is in internal one. You take that into matrix, and matrix dot accuracy. Here I can just see a okay, star 100. I'll just show you. um, just a fancy stuff, nothing else. The result comes. Okay. Okay, once you get this, it shows the result. It says 50%, 30%, 35%, 50%, 80, 90, or whatever it is. It shows the metrics. With this test, all those things, you can now, this is done. You are done with your engine steps. Now, create prediction engine related to loaded train model. So, at this step, your accuracy, everything has been decided. Okay, so using this structure, you create a engine, prediction engine, that is ml context dot model dot create predictions engine of this structure. This is the input, this is the output structure, using this particular train model. Okay, this is just a prediction, nothing else. So that's why whatever you are doing the training, that is the main stuff. Okay, you can see here, this train model is here only. Here only it is loaded. That's last. Whatever you're doing it here, that's different case. So prediction engine is ready, and then you are able to test. How you are testing this prediction engine dot predict in real time? What you can do, till this particular code has built in some different place, and then call that function or some particular engine dot predict. That's it. You will be calling just one line of code. Predict of this input string. If you pass the input string as a string, it's awesome. It means then it is a good, or it's bad means it is bad. Like that we can do. So, and here just a few more conventions. Already I was telling. So for this, column name is called label. Label means input data. What is this? Teaching result. Okay, whenever you're training, it's not teaching, you can think of, let's try to use the single convention, training data. Input training data, uh, result, you can say. Sorry for the noise. Input training data result. Okay, assumptions are result. Okay, and then this is for input data, input or testing data. You can think input test, sorry, training or test data structure. Okay, and once you get the result, that is called output, that is called predicted result. Okay, we have to, in the AI they use the word prediction always. In the normal coding we use the word output. Okay, here the difference is simple. You can use this word, emotion, this is the input, this is just an input, nothing else. And output is this particular one, whether it's a positive or not. This is you have to define with the term predicted label. Even I spend nearly half an hour without mentioning this as just as label. Okay, that's why this label convention is very much necessary. Here label, here label, just a label, uh, and here this is predicted label. Okay, this is for the sake of input, this is for the sake of output result. Okay, so totally, if you understand properly the few terms, inputs are called features, data features and label. Okay, outputs are called, you can think of like it's better predicted label. Let's not add much more confusion again. Okay, yeah, that's it. That's all about I did. Nothing else. I just created a console application and I just added ml.net NuGet packages to this. Okay, quickly I'm running. To avoid the time, I'm just coded all these things. I'm just pushing this to GitHub repository and I'm mentioning that in the text of this video. Hello world, it says something. It started the program. It says AUC is not defined when there is no negative class in the data. It means you can understand the data. AUC is not defined when there is no negative class in the data. It means the data is not enough. So usually this comes, if you are not able to understand, it's better I will just make you one quick idea. You have the test data, the data is not enough, the data sample is not enough, the machine to understand, it's not like a exact equal comparison, it is beyond that. So for that you have to make test data is also important for validation. Okay, so I'm just making it 50%. I mean, what are the data I have in that? Let me make it 50-50. Use 50 for training and 50 for testing. Because to measure the metrics, you need that. What is that? Okay, it got loaded. You can see here, accuracy is 83.3334%, and the result is true. It means it is tried for awesome. Now let me run it again with some different value. Instead of rerunning, I'm just running it back because it takes some little time just to save time. It's bad. Okay, I just made it's bad. What it says false. Okay, it is a simple thing. And again, don't think this will cover all the scenario because my data is very much very minimal. Probably it is not even 30. So then how can you expect it covers all the scenarios? No, you need to train with lot of scenarios. Okay, this is all about how to set up this particular ML context. Here the NuGet package is also very simple. Microsoft.ml is the main one, that is where ML context, all those things. Microsoft.ml.data, this is the one required for what is that data weave. Okay, uh, yeah, that's all about this particular. Keep coding, keep making brilliancy. Let's make the lot of things open source. Your Microsoft is doing this ML context as a open source, and so let's contribute everybody. At least let others will be running learning for this in a good shape. Thank you. Keep coding.